Hello, my dear students. I am going to deliver today a lecture on green chemistry. The important things which chemists make are such as medicine, materials like plastics, metals, coatings like paint, electronics like cell phones, computers. The major investigations by chemists are to understand things in the world around them. Global problems, the ozone layer in the atmosphere, natural processes, what is in a flower that makes its petal a particular color. Now I am coming to the point, green chemistry. For the fulfillment, the demand of modern human civilization, chemists are bound to prepare various types of chemical products in chemical industries. Maximum of the chemical products are hazardous substances. To minimize or prevent the production and use of such hazardous substances, it is important task for a chemist to develop some novel technologies for inspiring the new generations. This branch of chemistry which motivates the generations to follow the principle prevention is better than cure is the green chemistry. The motive of this branch to design the chemical processes and products that will minimize or eliminate the use and formation of hazardous substances. The main aims of the green chemistry. The main aims of the green chemistry are eco-friendly chemical technology, replacement of organic solvents to minimize the waste product, the use of renewable feedstocks to minimize energy consumption, use of more eco-friendly chemical products, and 4 Rs, and integrated waste management. These 4 Rs are reduction, recycling, reuse, and recovery. Now I am going to details on that matters. First of all, the eco-friendly chemical technology. Green chemistry aims to protect the environment, and this is why it is also described as environmentally benign chemistry. Second point is replacement of organic solvents and to minimize the waste product. Green chemistry aims to devise greener reaction conditions for the synthesis of chemicals so that waste product, especially the toxic waste, formation can be minimized. It needs the replacement of organic solvents by water or complete elimination of the use of solvents. It also needs to minimize the formation of byproducts, especially the hazardous substances. Third point is use of renewable feedstocks. Green chemistry aims to develop the greener synthesis of the required chemical products by using the renewable sources, just like biomass rather than photochemical feedstocks. It reduces the consumption of non-renewable resources, just like crude oil. Next point is to minimize the energy consumption. Green chemistry aims to develop the greener conditions for the synthesis of chemical products so that energy consumption can be minimized. For many existing chemical technologies, drastic reaction conditions, just like high temperature or high pressure, etc., which are energy requiring, are applied. Greenhouse synthesis aims to develop the mild or modest reaction conditions. Ideally, the reaction should be carried out at ambient temperature and pressure. Use of more eco-friendly chemical products. Green chemistry aims to design the new chemical products to replace the existing hazardous chemical products, provided the new chemicals are having the same desirable properties of existing ones. For example, the development of new pesticides which is only toxic to the target species and at the same time it biodegrades easily to harmless products. We have already talked about 4 Rs and integrated waste management. These 4 Rs are reduction, recycling, reuse and recovery. Now I am switching to the next topics, 12 principles of green chemistry. According to the formulation of Einstein and Warner, there are 12 principles of green chemistry to shape the environment and can be considered as blueprint for practicing green chemistry. This, these are given just here. Pollution prevention, number one. Second, atom economy, less hazardous chemical synthesis, designing safer chemicals, safer solvents and auxiliaries, design for energy efficiency, use of renewable feedstocks, reduce derivatives, catalysis, design for degradation, real analysis for pollution prevention. And last but not the least, inherent safer chemistry for accident prevention. Now I am going details point wise for that topics. First of all, pollution prevention. How we can prevent pollution? By minimizing waste product formation. It is better to prevent the formation of waste than to treat or clean up the waste after formation. And it is also called zero waste technology. And what should we do? Drive smaller, more efficient cars, take the commuter train, riding a bike, fix a leaky faucet, recycle paper or compost leaves. Second point is atom economy. What is the atom economy? Atom economy is a measure of proportion of reactant atoms which are incorporated into the desired products of chemical reaction. So, synthetic methods should be designed in such a way that maximize the incorporation of all materials used in the process into the final product. And the important aim of the atom economy is also the minimize the formation of byproduct. One motto should we think, waste not, want not. For a for the chemical reaction, Here I have given a chemical reaction A plus B, which converted into the product plus C plus D. Atom economy means the maximum product formation. Next point, less hazardous synthesis.